All right, and we are back at it again this week with some more circle things. This week we are going to be talking about arc length. So we're going to be moving forward from those angle theorems. Now we're going to talk about different measurements that we can find. So we've already been talking about different degree measures. So if we had like an arc AB, this is a minor arc because it's less than 180 degrees, it's smaller than the diameter. So if this is AB, and in this case they're telling us AB is 120 degrees. I'm going to write that on there. And then we're looking for ACB. So that one is a major arc because it goes through has 3 letters here, and also it's definitely bigger than 180 degrees. It's bigger than half the circle. So that's the one we're actually looking for. If we know a circle is 360 degrees, that would be the total. We know AB is 120. I'm going to subtract that away. We're left with 240 degrees. And that's what it is from A to C to B. So that's the distance it is. Now, all of those times we're saying it's 120 degrees, 120 degrees, but that didn't have anything to do with the size of our circles. Today we're going to go into the actual length of what's going on. So if we are given that A to C to B is 240 degrees, and we know that our radius is 6 inches, we can also figure out the measure of this major arc ACB. So let's look at this. Here is our formula for that we'll be using a lot today. Arc length. Now, when they do arc length, they do capital L for length because that's more important. We're looking for the length of an arc. And it's equal to the M, which stands for the measure in degrees. So that's that 120 degrees or the 240 that we were just talking about, times, or divided by 360 times 2 pi r. So what is going on here? If we look at this formula, like how did the mathematicians come up with this? This 2 pi r should look familiar. 2 pi r we've seen before. We did this way back in chapter 10, I believe. 2 pi r, this is our circumference formula. And circumference is just the circle version of perimeter. It's the distance around the outside of a circle. So if this is our total circumference of the circle, we could figure that out easily. Our circumference here is 2 times pi times the radius, which is 6 inches, which is 12 pi. So if we do that, that's easy enough. We could easily figure that out. But then they also have this m over 360. What is going on here? Well, what's going on here is this is telling you what portion or what fraction or what section of the entire circle are we looking for. So if we are looking for what is the length of A to B, this guy right here, this isn't the whole circle. This is 120 degrees out of the total 360 degrees. So if we can figure out this fraction, what portion of the circle we're looking for, when we multiply that by the actual circumference of the circle, 2 times pi times the radius, which radius is 6 inches here, that will give us the arc length of this circle. So from A to B, this arc length, the length of that arc is going to come out to be 120 over 360 simplifies, that's a third, times 2 pi 6. So I'm going to multiply all this together. 2 times 6 is 12. 12, a third of 12 is the same as 12 divided by 3, which is 4. So 4 pi is our most exact answer. Or if I ask for an example or an answer in terms of pi, pi is going to be in your answer. So 4 pi is our best answer. If I type this in my calculator, though, I'm going to put the squiggly equal sign because it's roughly equal to, or it's estimated equal to. Comes out to about 12.6. And I'm going to put our units as inches. So those would be our answers there. All right, so if we do the same idea, what is the length of arc ACB, that major arc there from A to C to B? We already figured out it's 240 degrees. Now we're going to use this arc length formula to figure out what the actual length of ACB is. Well, if we use our formula, we know length of our arc is equal to the measure in degrees, 240, out of 360 total degrees it could have been, multiplied by our circumference, which is the same thing as our circumference in the last question. So 2 times pi times 6. Figure that out. This case, it's 2/3 of 2 pi 6. So 2 times 6 again, 12. 12 times 2 times the numerator is 24. 24 divided by 3 is 8. So we have 8 pi on this one, which if you type that in your calculator is roughly 25.2. And again, we have inches. So that's how this arc length works. We'll go through a couple more examples, 2 more examples here for you. So if we're looking at this, we're doing the same idea. And I'm just going to write up here, I'm going to write L equals m over 360 times 2 pi radius. That we still have that on here. We can use that for all our questions. So in this case, they're telling us AB is the diameter of the circle O. So diameter, again, splits in half. And if we know a whole circle is 360 degrees, it's actually kind of nice because now we know if we're looking for ACB, ACB goes here. That's from the edge of the end point of the diameter to the end point of the diameter. If that's half the circle, whole circle is 360 degrees. 360 divided by 2, you're left with 180 degrees here. So now if we're looking for the length, we need length equals the measure, we said it's 180 degrees, out of 360 total, times 2 times pi times our radius. Now radius is half of the diameter. If we know our diameter is 14, we're just looking for this piece. 14 divided by 2, you end up with 7 centimeters as our radius. So if you want to type that on your calculator, it's half. 180 over 360 is the same as a half, times 2 pi 7, and that's kind of nice because 1/2 times 2, those cancel each other out. So we're left with 7 pi as our length of that arc ACB, which is the same thing when you type it in your calculator as 22.0 centimeters. And we're just going to keep centimeters there for each of these. I don't care if you do it in terms of pi. I don't care if you put it in your calculator and get a decimal. Either way, it's the same idea. Last one, if we look at example 3 here, JL, this arc J to L, oh, it's a little guy here, is 20 degrees. What is the length of JL is our first question. Well, we're still going to use this formula. L equals 20 now over 360 times 2 times pi, and our radius in this case is 2 meters. So this is going to come out to 1 over 18 times 2 pi 2, which comes out to, actually this is a really not nice fraction, 0.22 repeated pi meters, or it's the same thing as 0.7 meters when you type it all in. Either of those will be nice. And the last one then is the other end of it, this large major arc. So we go from L to K to J, this whole thing here. We still want to use our arc measure, but we don't know the degrees in this case. We know the whole thing is 360, so 360 minus the 20 that's JL, we're left with 340 degrees. So 340 out of 360. I just typed all that in my calculator. I ended up with 3.7 repeating pi meters. Or if you type that even further in your calculator, you end up with 11.9 meters. Either of those are acceptable. All right, that's all for your videos for this week. If you have any questions, please feel free to reach out by email or Google Classroom. I'd love to answer any of your questions. Bye, everyone.